So in this video, we're going to talk about the idea of catalytic hydration of an alkene. Now, I wanted to show you guys a diagram to kind of appreciate why we may need to use these reactions at time, right? So the graph on the left is without a catalyst, and the graph on the right is with a catalyst. Right? So the idea here is that with the catalyst, you can see that the energy barrier, or the hill that we have to climb, is less steeper than that without it. Right? So this is why or catalyst may be important. So let's look at the reaction. If we take any alkene, in this case, let's use this example. And we add hydrogen and hydrogen gas, and we add a catalyst, we essentially get rid of the double bond, right? So we essentially add our hydrogen on either side of the double bond, right? So here we're on the left hand side, we had our original hydrogens. On the right hand side, as a product, there's our H2 that we added. So that's the idea of catalytic hydration of an alkene. Now, some of the catalysts that we could actually use is palladium and carbon, right? So you have to remember these reagents. So these are palladium on activated carbon. You could also use platinum as a reagent. You could also use a nickel as a catalyst. And the other common one you actually see is ruthenium, which is Ru. So again, you use hydrogen gas in any of these catalysts, and you get rid of the double bond. You add hydrogen on either side. Now, one thing that you also have to remember, which is kind of the same thing with respect to hydroboration, is that the hydrogens, if we're asked to show stereochemistry, the hydrogens are added syn, right? So the hydrogens are added in syn addition. So let's look at another example and kind of see what do we actually mean. If we take this alkene, we had hydrogen gas and palladium with palladium on activated carbon. Again, really what we're doing is taking away the double bond. So in other words, remember we said that the addition is syn, and so essentially what I'm saying is that the hydrogens adding across the double bond are going to add on the same side, right? So notice that these are on the same side, and this is what we call syn addition. We could also write this as where the hydrogens are actually going away from us. Again, doesn't matter, they're still syn with respect to each other. So either or is correct, there's still syn addition. So catalytic hydration is pretty simple. Again, you take any alkene. If we do another example, we take any alkene and we add hydrogen gas on a catalyst, we essentially get rid of the alkene. We essentially get rid of the double bond.